Okay, we are team number 23, and we're gonna talk about problem 11. For subproblem A, let's draw the K-map first and fill in the corresponding midterms. Okay, we're done. And now, we're going to find the prime implicants. A prime implicant is a group of ones on a corner map that covers as many ones as possible in a rectangular block of size a power of 2. So, here is a prime implicant, and we call it maybe P1, and it's midterm 2, 3, 6, and 7. Here is also one prime implicant, and it's P2. And it's midterm 4, 5, 12, and 13. Here is also one. P3. And it's 4, 5, 6, and 7. And P4. It's midterm 9 and 13. And also, here is 1. And let's call it P5. Okay, we're done here. Then we need to find essential prime implicants. An essential prime implicant is a prime implicant that covers at least one midterm that no other prime implicant covers. So let's check. Oh, sorry. There's one. P6. Nine and 11. Okay, we got 6 prime implicants, and now we need to find essential prime implicants. So let's check from P1, start from P1 to P6. In P1, we can see that the midterm 2 here, it can't be covered by any other prime implicants. So P1 is an essential. And what about P2? P2, the 12, the midterm 12, it can't be covered by any other. So P2 is also prime implicant. And how about P3? P3, the 4, 5, the midterm 4 and 5 can be covered by P2. And the midterm 6 and 7 can be covered by P1. So P3 is not an essential prime. And let's check P4. P4, midterm 9 can be covered by P6, and midterm 13 can be covered by P2. So P4 is not. And what about P5? P5 is also not, because 3 can be covered by P1, and 11 can be covered by P6, so P5 is not. Then what about P6? P6, the midterm 9 can be covered by P4, and the midterm 11 can be covered by P5. So P6 is also not an essential prime. So the essential prime implicants are only P1 and P2. Okay, and now we need to express the results as n terms. Then we choose P1, P2, and P6 because they can cover all the ones in this column map. And P1 is A prime, C. P2 is B, C prime. And P6 is A, B prime, D. So the final result of F is A prime C or B C prime or A, B prime, D. Okay, so now we have 6 prime implicants, and P1 and P2 is essential prime. And the left 4 prime implicants, P3, P4, P5, and P6 are not essential prime implicants. They are only prime implicants. And P3 can be expressed as A prime, B, and P4 is A, C prime, D, and P5 is B prime, C, D. So this is the final answer.
To find all the prime implicants for the given Boolean function, we start by drawing the K-map for the function. Next, we are going to identify all prime implicants. A prime implicant is a product term obtained by combining the maximum possible number of adjacent squares in a map. In other words, we need to group the squares in size that are powers of 2 as large as possible. So we can find here is a prime implicant, and we call it P1. P1 is composed of midterm 6, 7, 14, 15. Here is a prime implicant. We call it P2. 8, 9, 12, 13. And here is also a prime implicant. We call it P3. Here is a prime implicant. Call it P4. Here is a prime implicant. We call it P5. Here is P6. One and 9. After listing all the prime implicants, we determine which of them are essential. An essential prime implicant is one that covers at least one midterm that is not covered by any other prime implicant. Now let's check P1, and we can find that midterm 6 is only covered by P1, so P1 is essential prime implicant. How about P2? We can find that midterm 8 is only covered by P2, so P2 is a essential prime implicant. Next, P3. In P3 we can find that 14 is also covered by P1, and 15 is also covered by P1 too. It's also covered by P1. So P3 is not essential prime implicant. P4. In P4 we can find that midterm 3 is also covered by P5, and 7 is also covered by P1. Next, P5. We can find that 3 is also covered by P4, so P5 is not essential prime implicant. Next, P6. 1 is also covered by P5, so P6 is not essential prime implicant. Okay, so essential prime implicant is P1 and P2, and P1 is P1 X and Y. P2 is W and Y prime. Owner prime implicant. Owner prime implicant is P1 to P6, and they are and P3 is W and S, and P4 is W prime and YZ. P5 is W prime S prime Z, and P6 is X prime and Y prime and Z. There is our final answer.